Now let's talk about covalent bonds. Covalent bonds are the ones that are formed when two nonmetals share electrons to complete the octet. The valence electrons in this case are not going to transfer, but they are going to be shared to gain stability. So, fluorine, for example, has 7 electrons in the last shell, and it shares with another molecule of fluorine, and then each one of these fluorines will have an octet, and they are forming what is called a covalent bond. There are molecules that exist as diatomic molecules, and they form covalent bonds: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So what is the name of each of the following diatomic molecules? This is hydrogen, this is nitrogen, chlorine, oxygen, iodine. So the bonding pattern of some nonmetals is going to be based on where they are located in the periodic table. So for example, hydrogen likes to make what bond? Boron is an exception, likes to make 3. Carbon and silicon, they are in group 4, so they like to make 4 bonds. Nitrogen and phosphorus are in group 5, and then you do 8, because it's the octet minus 5, they give you 3, so these like to make 3 bonds. Oxygen and sulfur are in group 6, you do 8 minus 6, that give you 2, so they like to make 2 bonds. And then all these are in group 7, so you do 8 minus 7, give you 1, they like to make 1 bond. So how do we draw the electron dot formulas? First, you determine the arrangement of the atoms, then you determine the number of valence electrons. You add each atom bonded to the central atom. Which one is going to be the central atom? The central atom is going to be that element that can make more bonds, and then place the electrons that you have. Let's do these examples together. Nitrogen, NH3. Let's do the formula. Nitrogen comes with 5 electrons. Hydrogen comes with 1, but we have 3 hydrogens, so that will be 3 plus the 5 of nitrogen, that will be 8. So we have 8 electrons to work with. We have nitrogen and hydrogen. Nitrogen likes to make 3 bonds, and hydrogen likes to make 1. Therefore, nitrogen is going to be the central atom. We put all the hydrogens around because hydrogen only likes to make 1 bond. We have 8 electrons, so we place 1, 2, 3, 4, 5, 6, 7, 8. And then what we do is we're going to share the electrons. We share here, make a bond, share here, make a bond, and share here and make a bond. We're going to do the same for CCl4. CCl4. Carbon likes to make 4 bonds and chlorine likes to make 1. So carbon is the central atom. Each chlorine is going to be around because chlorine likes to make 1. Carbon comes with 4 electrons and chlorine comes with 7 times 4. So that is a total of 32 electrons that we have to play with. So we do 1, 2, 3, 4, 5, 6, 7, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. And then what we do is share this pair of electrons between chlorine and carbon to make single lines. And this will be the Lewis structure, or the dot structure, for CCl4. Not all the atoms have octets. For example, hydrogen likes to only have 2 electrons, boron likes to have 6, beryllium only requires 4, And some others like phosphorus, sulfur, chlorine, bromine, and iodine can have up to 14 electrons. So we can have single bonds, or we can have double bonds or triple bonds. Please remember that every time we have a bond, that means that we are sharing a pair of electrons. If we have a double bond, 2 pairs of electrons, and if we have a triple bond, 3 pairs of electrons. So let's draw the electron dot formula for CS2. Carbon likes to make 4 bonds, sulfur likes to make 2, so carbon is the central atom. Carbon comes with 4, sulfur comes with 6 times 2, so we have a total of, this is 12, 16 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 10, 12, 14, and 16. So now what we need to do is delete this and make it a single bond. Carbon in this case will have 8 electrons, but sulfur, if we see, we have 1, 2, 3, 4, 5, 6 is not complete. So what we're going to do is delete that one and put it here, and we do the same here and do that, and now everyone has 8 electrons. Resonance structure means when we have 2 or more electron dot formulas that can be the same. And what it is just changing the position of the double bonds. So, for example, if we have this molecule and if we write a resonance structure of that, we could either have the double bond between these 2 or between these 2. This will be a resonance structure of that molecule. What does it mean? That we have only changed the position of the double bond. In this doesn't make much difference if we had it between these 2 or if we had it between these 2.